Today I'm measuring every single RV electrical component in my trailer, and we're going to answer 4 simple questions. How much power does it actually use? Is that a lot of power or is it a little? And what does it mean for your batteries when you're camping? And finally, should you even worry about it? By the end of this video, you're going to know exactly where your power is going in your RV trailer and where it isn't going. Okay, we're going to go with the one that I think is drawing the least amount of power here. And my trailer has all been switched over to these small LED lights here. So we're going to measure exactly how much these little LEDs are using. Okay, so we've got on our meter here, we've got, let's see if we can zero this out. Let's just look for that number to increase. Here we go, 0.12 of an amp. Turn it off, you can see it go down. Turn it on, we can see it go up. This is very minimal amount of electricity that we're using here, and I'll tell you exactly what it applies to. Now, although this LED configuration is a little bit different, it's still got about, you know, as many LEDs. Even if it has twice as many as the one on the inside, we're still not drawing that much power. So if you want to solve the age-old argument, don't leave the light on, the porch light on all night, because you might kill the battery. That might not actually be true. If you got an incandescent bulb, I can't actually tell you that, because today we're testing LEDs. So I'm going to suggest that your exterior lights, your interior lights, unless you're running them all at the same time, all night, every night, I don't actually think it's a problem. There's very little electricity used by running your LED lights for any length of time. Okay, next we're up on the roof here, and we're going to measure the bathroom fan. Bathroom fans typically got a pretty small motor. Just going to see how many amps this thing draws, how many watts it uses at one time. You can see it's running right now. We're going to clip on here. Oh, really? Awesome. I just unplugged it. Okay, give me a second here. What? Oh. Okay, so we're going to clip onto this. And we have got 3.8 times 12. We're looking at 4.5 watts. So very, very little wattage being used by that fan. So I'm going to suggest that even if you leave your bathroom fan on, you know, you've gone out, you've done all your stuff, and you come back, that little motor is not killing your battery. So don't worry about that fan. It's quite a bit bigger motor, but let's actually figure out how much this is using. So this is pretty typical fan that you'll see on RVs. And actually, you can see how my circuit board here is corroding a little bit here from the moisture outside. If you haven't checked out my RV vent fan fix, you might want to check that out if you're having an issue with yours. But let's do a measurement here on this. I brought the remote control with me. It's actually, let's turn it down because I want to start from the bottom end and show you something as well. Right now we're at 10%. Lift that up a little bit so we can see a little bit better. And we're going to clamp into here. And we have, you can see that, 0.45 of an amp, which equals 5.4 watts. That is not a lot of wattage, let me tell you. Let's just crank it right up, 100%. We're still only like a half an amp, so we're still only drawing about 7 watts. 7 watts is not a lot of power. Like, it is so little, it's not even funny. I'd feel confident just leaving this fan running 24/7 if I wanted to keep air circulation going through my RV trailer at any time. I've got some solar panels here. You know, there's a bit of sun on them. I don't have to worry about anything that we've seen so far for using power. Use it as much as you want. Okay, so now we're inside the trailer. One of the things that I wanted to check out was the water pump, right? So how much power is the water pump actually using? Let's answer that right now. Now, I'm sure that there's water pumps of different sizes here as well, so we're good there. Let's turn the water pump on. And we've got 3.3 amps there. So 36 watts. Turn it off, turn it on again. Okay, so that's an intermittent use item, and I still haven't found anything in this trailer that is gonna cause me worry for power draw. So one of the things I'm curious about, I've never been able to measure this. This is kind of the cool thing about having a YouTube channel. We get to buy more tools so we can test things. It's kind of cool. But anyways, what we're gonna do here is I'm gonna turn my inverter on and see how much power it's using, hopefully, without having anything plugged into it. So when it's just sitting there static, I want to see how much electricity it's using. So right now I'm at, let's call it 0. Okay, so we've got the button on inside now. We've got 0.8 of an amp. So we're still only running about 10 watts to have that inverter on. So the amount is actually quite negligible. Like it's not very much at all. We still haven't found any power users here that are just sucking the life out of your battery while you're just sitting here idle. Let's keep looking. Next, we're going to move on to the hot water tank. Now, my hot water tank is gas fired, but it still has a little solenoid there that takes power to enable the whole system to work. So we're going to measure that and see if that's something that we need to worry about. Okay, so we're going to have that zeroed, and let's go turn on the hot water tank. Okay, so you can see my flame going here. The gas is doing most of the work here, so we're really only just holding the solenoid open here with electricity, and we are at 0.65 of an amp, so we're sitting right around, say, 10 watts. So very, very minimal to drive that hot water tank with our batteries. If you wanted to keep your hot water tank on, just keep it on like this. We really haven't ran into anything here, especially if you got a little bit of solar, for anything that's going to amount to anything draining your batteries. So the hot water tank actually kicks on and off intermittently. Maybe if I left that on through the night, it probably would only come on, I don't know, maybe once, maybe twice during the night. So just, it's not using very much power, not something to worry about. Okay, we're down to 3 more systems that I need to check. Join me on the other side. We're going to go and check the furnace. Let's see exactly how many watts that furnace is using when it's needed. Now the furnace is one of those big ones, you know. It's definitely not something that we have to use so much in summertime. Although, to be honest with you, it kicked on once this morning already. A pretty big motor here, right? So, okay, so I really like verifying things here, right? So this is a good opportunity to see if it actually fits. So we've got the model number here of this particular fan, 8525. And we can go down here, 8525, 12 volts, and amps, 5.5 amps, 66 watts. Let's see if that is doing exactly that or if it's something else. And we'll turn on the furnace and see if we got something close to what that sticker says. Okay, so our fan is running and we've got 6 amps. And the sticker said 5.5. We're actually not that far off here. So we've got 6.6. So we've got 79.2 watts that we're using here. Not 66 and it's not 98. So we're right in between those. But at least we can verify that the sticker is pretty accurate. So at 80 watts draw on your furnace is definitely up there, but nothing that's gonna, kill it because it's not running continuous. That's something that you want to consider. Usually when you're using your furnace though, it's cold outside, right? So cold affects batteries as well. In particular, it'll affect lithium batteries even more so. That's why they got heaters built into them. Those are things that you have to kind of consider and manage as time goes on. Definitely for most summer users, it's just not something that we need to be concerned about. If you're boondocking in the colder temperatures, definitely something that you want to manage your battery bank for. Size your battery bank, even size your solar panels to be able to rejuvenate those batteries during the daytime. The fridge is definitely where it gets interesting. My fridge runs on 3 different power sources for cooling. It can be on gas, it can be on AC, and it can be on DC. I've never actually been able to measure until today what those power requirements for. I do know that when you're boondocking, you definitely want to be on gas, but today we're going to actually be able to measure it and figure out just why that is. Let's go and measure how much electricity the fridge is using on gas, and it's essentially just powering up this panel is all it's doing. So let's go take a look. Okay, so on my fridge, this here's the 12-volt power connection that feeds the fridge when it's running on 12 volts, which it is right now. You can actually unplug this 120 volt connection here for AC. We're running on the batteries right now using gas. Let's see how much we're drawing. And we've got 0.72 of an amp. So we're still under 12 watts. Let's work it out. 0.72 times 12 equals 8.64 watts. So very little wattage required to just run the circuitry on the fridge. Let's see what happens when we switch over to DC. Okay, we're switched over to DC, which means we're running off the batteries. Okay, so we've got our refrigerator cooling now, and it is running at 20 amps. So, as you can imagine, that is definitely a high power user. 20 amps times 12 volts is 240 watts that it's drawing right now to heat this element here for cooling the fridge. Okay, so we're going to switch over here. We're going to measure the actual wattage using AC current. So we're going to plug that in, plug our refrigerator in. Okay, so now we can see our DC volts have dropped down to 0.79. So this is the electricity being used by the batteries to power just the electronics component of things. And what we have here, if I can get it to wake up, 564 watts. Holy mackerel. So that's just kind of starting up here and getting things going. So AC current really running that fridge hard here to get it cooled down. Wow, that's really high actually. It's good to know what these loads are, right? And so when we're trying to do things like run our air conditioner, right? We've got our generator running, we start our air conditioner, and we've got our fridge automatically switching over to AC current because it wants to automatically default to using hydro from your power source. It overloads the generator, right? So make sure that when you're switching your AC air conditioner on, that you get your fridge into gas mode, because that's going to help actually get that thing started and running again. And speaking of air conditioners, the air conditioner is the last one that I'm going to check here. I actually suspect that it's going to be the highest power user, because that's the thing that everybody struggles with when they're firing up generators trying to get their AC units to work, right? So we've got that initial surge power that's happening, and then it's just gonna run there somewhere. So I've actually got my AC turned on right now because my cat is just dying of heat out here. Let's take a measurement and see where it's at. My particular air conditioner is a small unit. Its BTU is only at 9,100. I know a lot of you out there have 12,500, 13,500 BTU air conditioners. I can only go with what I have. So you could probably figure that out. You know, on the sticker on the unit might have some more information of what that actual power draw is, but let's go find out what mine is. So I can't actually measure this because my wires aren't separated, but I'm gonna go off of the BTU stamp here. 1,530 watts of power required to run this AC unit. It's probably fairly accurate because I can get this thing going with my 2,000 watt generator. It takes a little bit of finesse, but I can do it. So to give you an idea of just how much energy that air conditioner is taking, 1,530 watts of continuous running that it's drawing. So when you do the math on my battery setup here, let's say they were brand new 100%, 215 amp hours, I could actually only run that air conditioner for about 45 minutes before my battery's at 50% and they're dead. If you had lithium batteries, you can probably go a little bit longer because you can discharge them further, maybe get an hour and 15 minutes out of those batteries, but that's it. But that's a super high draw on your batteries running any AC unit. So after measuring every built-in electrical system in my RV trailer, a few things really stood out for me. First of all, don't sweat the little things. The outside light being on, the water pump usage, that kind of stuff. They're very minimal power draws. Secondly, it's the appliances that run for long periods of time. Your fridge is an absolute power hog. And I'd actually like to hear from some of you that have maybe been able to test your RV fridge that have full-on electrical only fridges, the 12 volt DC fridges. It would be interesting to see what those things are actually drawing. The other appliances like your furnace running overnight, you know, yeah, it's got, you know, it was 80 watts. It's a fairly significant power draw, but it's not on continuously, and that's what matters. The refrigerator is probably the one that's going to bite you if you're out in the middle of nowhere, just by simply having the wrong setting. So remember, you don't save battery power by guessing, you save it by measuring. And if you found something useful in this video, click that like and subscribe. That's what we do on this channel. We answer those everyday questions that everybody has. And hey, we'll see you at the next one.